Very good afternoon to all of you, all the participants who have joined online from UITTR Chandigarh as well as from other centers. As Madam told you that I am a mechanical engineer, so whatever I talk would have some linking to mechanical engineering. Now the topic given to me is project-based learning. If I want to finish it in one line, I will say that it is a teaching learning process. It is a teaching learning process where the students work on projects and learn. That is all. But let us see why we need project-based learning. What do we do in project-based learning? What are the benefits? How it is different from our normal approach of learning? Now let's see what is project-based learning approach. So it is basically essentially a teaching learning approach or instructional approach which is getting popular these days. Many people I have seen they are using that they start with project-based learning only in the first or second year itself. So let's see what is project-based learning. Project-based learning is an instructional approach in which students get an opportunity to develop knowledge and skills by engaging themselves in real-life problems which they are expected to come across in the real world, or somebody else is facing these problems. It can be a problem given by somebody else also. These problems may not be very discipline specific. They may be multidisciplinary problems and complex. Project-based learning. If you go to the second line, real life and real world problems are always multidisciplinary. Let's say somebody is a mechanical engineer, not necessarily the problem will be solved by using just mechanical engineering. Maybe you need some computer science. Maybe you need something of electronics. Maybe you need something about the motors. And they are complex. What is a complex problem? Complex problem is the one where there is no simple straightway method of solution, and it may have more than one solutions. Complex problem is one which has probably not been solved earlier. Complex problem is one for which there are no standard procedures of solving, or there are no Bureau of Indian Standard codes or ISO codes available. So we have to develop the capability of solving the complex problems. If you go to NBA PO's program outcomes, complex problem solving is repeated at 4 or 5 points in 4 or 5 POs, which NBA wants, or is the expectation from an engineer when he passes out. Now, why do we want the people to work and learn? This is an old proverb. It says, tell me and I forget. That means you teach me. You tell me a story, I'm likely to forget. Tell me. And teach me. I will remember. But by doing, by involving in the process, I learn and remember. I will learn. The focus is on learning, not on remembering and repeating, not on forgetting the things. The focus is on learning and be able to do it, or learning how to do it. If you analyze the learning pyramid, it says if you give a lecture to somebody, the retention will be only 5%. By reading, 10%. And if you go down, practice by doing is 75%. And if you teach others, or you use it immediately, or in solving a problem, the retention is around 90%. This is some data taken from the internet. So I don't have any authentic proof for this. It is taken from a uh, from internet. Now let's see what is a project. Projects are integral part of all educational programs to attain the program outcomes. Because we are all teachers, and most of you are teaching in engineering colleges. Of course, there are people who are teaching in education departments also. We have projects in all the programs. UGC has made it compulsory that you should have projects. It is a part of the curriculum. Now, why do we have a project? Project is basically because it develops ability to apply knowledge in practice. Whatever you have studied, the students have studied, they should be able to apply that knowledge to develop a project. You see, that is what happens. Let's say in engineering, you have the project in 7th or 8th semester. That means the presumption is that we have already given the enough inputs to the students, and if by applying those skills and knowledge, the students will be able to develop a product. Ability to analyze and synthesize. The student will be able to do the analysis of the things. Problem solving skills, how to solve the problem. Just by seeing the question or problem, the student should not say that I don't know it, how to solve it. He should try, he should look for different ways of solving it. Maybe he'll come to a point where he says, I have solved the problem. Application of norms of standards. There are norms and standards. There are environmental requirements. There are, let's say in mechanical engineering, we say there are some standards on this dimensions also, weight also, requirements of the customer also. So that also has to be kept in mind, and the student will learn by doing the project only. Information management skills, where the information available and how to use it. Maybe the project is already done and it is available on the some information media like internet, and you don't have to do it again. Let's think of something else, or let us try to improve that by using different methods. Planning and time management skills, how to plan the project. The project planning is important. You see, we use that PERT and CPM in project planning. And time management, the student should be able to give the project, to make the project, to develop the project within the given time slots. Communication skills, all writing, verbal, and graphical. Sometimes you don't have to write many things. You give a graph, you give a bar chart, and everything is clear. So that also is probably developed by doing the project, because you have to give the presentations. Innovativeness and creativity skills. Project is supposed to develop these skills also. Ability to work autonomously as well as in teams. Individually as well as in teams, as a team member, as a team leader. You see, all these things project will teach you. How to distribute the work amongst the team members, how to motivate the team members, how to collect the work, how to meet the timelines. All this comes from the project if it's taken seriously. Critical and self-analysis abilities. We say the students should be able to see or analyze it critically and reflect on themselves also, that I have done this, whether I am doing it correctly or not. Interpersonal and decision-making skills. Decision-making is very important, and justifying the decision also is very important. Initiatives and will to succeed. They should not leave in between that, ye nahi ho sakta. And research skills. Of course, very important aspect of this, which is not written here, is the financial viability of the project. what materials he or she will select, what processes should be used. All that parts forms a part of the project, because we want to make a project which is acceptable, or probably it is sellable also, which meets the social obligations also. PBL basically is based on real life application. That means the problems are actual problems, real life applications. It is not like the projects we are doing, that we are basically, students are doing projects which are repeated year after year. PBL projects are thematic, relating to or based on the subject or a theme. Them likha hua hai, theme. It has a context which is very well known to the students, why they are doing it. That means the outcomes are defined, what you want to prove by doing this, or what work or what function it will do. You are writing a software, what it will do when it is completed. It is interdisciplinary and multidisciplinary also. What is the difference between interdisciplinary and multidisciplinary? There is a difference. Multidisciplinary is when people from the different disciplines, let's say mechanical engineer, a computer engineer, a physician, a faculty from physics or student from physics, they are working together to solve a common problem, but they are using their own knowledge. They are not mixing with each other. They are using their own expertise in the domain, their own domain, and give the solution to the problem. Whereas interdisciplinary is where people from different disciplines are working together, and at the end, these disciplines may merge. Like mechatronics, mechanical and electronics have merged to form a mechatronics disciplines, collaborative. It may not be a single-handed job. It may be, as I said, multidisciplinary, interdisciplinary, a big teamwork, small teamwork, or it may be sometimes needing the students to talk to some people from other disciplines with some expertise, so that the project can be involved. Why we do it? Because there is a requirement for changing, there's a change in the requirements of skills, what education gives, the transformation, what the education will do to the students. If you see 20th century skills and 21st century skills, it was just like filling the vessel, that we have to complete the thing. We have to complete the syllabus. That was all. Whereas now, it is basically we want to make the students, just see, under 21st century, it is kindling the fire. We want to make the students innovative, inquisitive, asking questions, probing things. 20th century skills required only retelling. That means you read something and reproduce that. And we call it as rote learning. Now, 21st century, they want to discover. It is required that we will discover and innovate something. We will do research. Information transfer. In 20th century, it was just information transfer from the, actually the teacher was reading from the book. So transfer from book to the teacher and teacher to the students. What here in 21st century, we want the students to learn how to keep learning, what we call it as lifelong learning, how to learn themselves, how to probe things. It was time-based. That means completing the things in time. It is just completing the syllabus. I will not say jobs. It is outcome-based, what the students have learned. Textbook-driven. Given the textbook, there are some questions given at the end of the textbook chapter, and you do it and you pass the exam. That was the aim earlier. Now it says no. You have to be innovative. You have to solve problems. Passive learners. Now it is, what we need is Active learners where the students will participate in teaching learning process. Now you will ask me a big question, where are the students who will do all this? The students are students, but we have to motivate them. We have to motivate them that this why they should do it. Now there are students who are getting 1.5 crore rupees package, and there are students who are getting 3 lakh rupee package per annum. We have to tell the difference why they are there. Why somebody is getting 10 lakhs, 15 lakhs, somebody is getting 3 lakhs only. Some people are not getting jobs because they are not able to prove that they have learned something. Now, this above difference between the 21st century and 20th century has brought us changes in the role of teachers, students, curricular delivery, and assessment. Now, the role of teacher has changed from transmitter of knowledge to guide and facilitator of knowledge. The teacher may not teach anything in the class, but he should be able to facilitate the students to learn. There are different methods of teaching learning, like flipped classroom, blended learning, PBL, project-based learning. Teacher was controlling the learning, how the learning will proceed. Now the teacher is creator of learning environment, that he will create the learning environment, tell where the things are available, and the students will learn themselves. Earlier the teacher was learning to use ICT. Now ICT is basically integrated into teaching learning, so that the teaching learning impact is there and it is enhanced due to use of ICTs. If you can give a simulation how a lathe looks like, if you can give simulation how a dam looks like, how a dam is constructed, how a tensile test is conducted, and what is the effect of the learning is much better. Teacher was always expert. Now teacher is a co-learner. He can learn, he may be learning along with the students. Earlier what happened? The learning of the teacher was static. Once he has studied, he will make notes, and I have seen teachers who will have notes which are torn out, they will put tape on that and they will bring it to the class and dictate to the students, where now the teacher is a lifelong learner. Every day he has to learn. Steers the class. Now, students' voice is important. Teacher has to do what students want. So, role of teacher has changed. In the changed role, we have to adopt new technologies, new methodologies, new approaches to meet the requirements of the students. Basically, the idea is to meet the outcomes of the program, what we want the students to be able to do. Similarly, role of learners has also changed. They were passive learners. Now they are supposed to be active learners. You see what was happening earlier. I just reading some article, they say, and I fully agree with that. It said that there are 4 or 5 students in the class sitting in the front row who will dictate how the teacher will go ahead. Whereas 55 students are not doing anything. They are neither speaking nor the teacher is giving any attention to them. So the class was basically steered by those 4 or 5 students. Now it is expected that all these students will be active learner. I know the question which is coming to your mind, how to make the students active learners. Students will become active learners only if you involve them in the class. If it is only one-way communication, that you are speaking and the student is listening or sleeping in the class, then it will not happen. Earlier, the Student was reproducer of knowledge. Whatever has been taught to him, he was reproducing only. Now we want the student to be producer of knowledge. He was a dependent learner. Now probably it is dependent, not dependent. It is now autonomous learner, solitary learner. Individually he was studying. Now it is basically cooperative and collaborative learner. Learning content only. Whatever is taught to him, he has to study it, he has to remember it, and he has to reproduce in the examination. Whereas now learning to learn, how to learn, from where the information is available. Think himself so that he can analyze the things. He can analyze the system. He should create something and communicate also. Communication has become very important, which is missing these days. Limited learning options. Now you have many learning options. Being static learner, now it is a dynamic learner. Everything there are changes. Fixed mindset. Now it is growth-oriented mindset with the student are expected to have and do have. There are questions which many times the teacher has to think twice to answer a question from the student. Similarly,
No.
yes, curricular delivery assessment, memorizing facts to inquiry based, artificial teaching exercise to authentic. Artificial is not artificial intelligence. It is not real. Real teaching, non-real teaching exercises, now authentic, real exercises we want. Rigid delivery, fixed time frame and fixed sequence. It is now open and flexible delivery. You can check, probably if there are no prerequisites, you can start from chapter 7 teaching. If you can do that. Single path progression. Now it is multi-path. You can have many inputs. You can start from anywhere and you can have many inputs. Monologue. It was a one way. Now it is two-way or dialogue and collaborative teaching. Analog and limited resources. We had only books. Now we have digital resources which are very easy to navigate and much faster to navigate. Delivery of information. Earlier it was there, now it is exchange of information. We say the students will come prepared by studying something and we will exchange information with each other. Examination. But now it is not only examination, now we have many other things for, at least for formative evaluation. Now how to do it? We have to change and transform attitude and thinking about the purpose of education. Purpose of education is not to pass the examination. Change the curriculum. Change the educational environment itself. Adopting current technologies, current instructional methods and so on. We have to change the system, starting from the curriculum, your physical resources, human resources, and the teaching learning process, as well as the assessment. By educating and training students in gaining not only knowledge, but also acquiring life skills and managing real life problems and challenges. It is not only bookish knowledge. It is basically applied now. It is applied knowledge we want. Project-based learning is one of the advanced pedagogical approaches as an instructional method which helps to learn and imbibe the real skills. Why do I say this? Because when you have to work on a project, you have to start thinking. Project is not a ready-made project with you. Project may not be static project. Project may be dynamic projects where you need real-time information also. You have to think about how to solve. You have to synthesize. The students have to synthesize how many methods are there of solving this. Then you have to scrutinize the methods. You have to evaluate the methods. You have to optimize the methods. You have to do literature research, what is available. You have to do what are the processes available for this. You have to, the students have to know from where the information they will get. Students will know that this is an electronics component. So let me go to electronics, sir, or my peers in electronics who will tell me how to use it. Because pure engineering is not the in thing, it is now out thing. A plain mechanical engineer cannot do without knowing computers, without knowing electronics, and without knowing electrical, maybe something of civil engineering also. We face that problem when we have to install a machine. Nobody know how to put the foundation for this. Then we have to talk to civil engineering. We have to find from the literature that, okay, this is to be done like this. Project consists of related and coordinated series of activities or tasks performed to realize a goal. Goal is known what we want to do. I want to make a, let's say, an item or equipment which will lift the heavy load. That means the goal is how to lift the load. When the student starts working on it, he has to think what are the associated problems with this, how to design it, what is the load I have to support, what are the safety precautions in this, what are the materials in this, what is the load I have to carry, or what is the total weight of the equipment which I have to make or design, all these things, and what is the cost of that, how to make this, what are the processes for that. Now these two lines, second and third line, I have added today. It says there are two types of projects. One is projects based on learning, which we are already doing in 6th, 7th and 8th semesters. That means you have learned many things. Now you want to apply based on your learning. That is what we are doing. But what we are talking today is learning based on the project. That we will do the project, students will do the projects. In doing the project, they will learn many things. That means it is not based on only prior knowledge. It is based on much more than the student knows at this stage. Maybe in the second semester, in the third semester, he doesn't know much things about the his discipline or in the allied disciplines. So if he is working on a project, maybe he has to find out what is required for this. What are the other disciplines he has to talk about? What is the processes he has to talk about? What are the safety measures? Where are the safety measures available for this? What are the standards for this? So this is where we are working on. This is a learning based on project. We are trying to the students to learn based on doing a project. A project may be structured or unstructured. Structured project is one where you know the solution, which has a ready-made solution of the processes. So structured projects have expected outcomes and solutions and techniques for solution. Everything is known. Everything is known. That you want to make a flask, it will be known, it will be made by injection molding, and you make it, there's no problem. The only thing is the size may vary. The die he has to cut. But more projects are on unstructured pattern, or they are open-ended and have no predictable or prescribed solution. Unstructured projects require students to consider assumptions and constraints. They have to come up with what are the assumptions they are making. If the assumptions are not correct, the project will fail. That means they have to think about what type of assumption they will take. And what are the constraints on this? Maybe the cost is constraint. I cannot make very costly project. Maybe the weight of the product is a constraint. Maybe the shape of the product is a constraint. Right? Maybe it has to be very safe. I cannot have sharp edges on this. So that type of assumptions and constraints the student only will come up with. If he starts thinking in that way, he learns many things. Unstructured projects thus require students to do their own structuring of the project. They have to come with a plan for this. How to do it? A process that enhances students' ability to solve the given problem. That's which will help the students, which will enable the students to think about, to develop the abilities to solve the given problems. It has been probably reported that students learn more from working on unstructured projects than they do on structured problems. You see, unstructured projects are like doing assembly, that you are given some things and you do assemble them. Whereas unstructured are where you are you have no prior knowledge how the things will work. You have to probe. The students have to probe. So those unstructured projects will give more information, more learning capabilities to the students. Unstructured projects are problem based. They are basically authentic projects which are likely to be there, or the projects are given by some industry also, they can also give, similar to the ones encountered by working professionals. You see, the projects are similar, maybe they may be smaller on scale. जैसे पायलट प्रोजेक्ट बनाते हैं, require creative and problem solving skills. It is just not a mechanical process. It is you have to think about it, you have to do it, and probably you have to redo it. You have to learn some things, you have to unlearn some things. Student-centric, the student assumes responsibility for their own learning, and faculty acts as a facilitator. Faculty will come into it when the student asks for it. Or faculty will find out where he is likely to go wrong. He can warn him. Involve self-directed learning. Required research skills. Students need to learn how to get information when it is needed, what are the sources of information, and will be current. That means he will be updated. Student will know where the updated information is available, and which is a essential skill for good projects, professionally managed projects. Reflection and learning. Excellent source of learning and imbibing various steps of higher thinking skills. What is reflection? These education people know what is reflection. Reflection is basically reflecting on yourself, what you have done, and going back and seeing what mistakes I have done and correcting yourself, or getting better information and better results. That means you look at yourself, what I have done, and try to correct yourself. What are the abilities needed for unstructured projects? First is the communication, verbal, written, graphical. Analysis abilities, how to analyze this. There are different solutions available, different processes available, how to analyze them. You think of a project, then you say, this is not feasible because I don't have a machine like this. Or this material is not available, what I am thinking. Assessment of the working. You should be able to assess also. Now, there is a difference between assessment and evaluation. Assessment is what we call it as formative assessment, where you try to correct. It is like your reflection. You do something, reflect on that, and assess it whether you are going in a proper way, and evaluate it where you want to go ahead or not. Execution and creation. Learn, unlearn, unlearn, and learn. This is very, very pertinent point, that in these days, you know something, maybe you have to unlearn it. And again, learn something new. It is like training and detraining. You have to detrain some people and train them in new jobs. So this was the traditional approach what we had. So teacher has knowledge, teacher gives direction to students, students follow directions, students learn facts by following direction, and students present facts. That is the end of it. Anyway, this is about the traditional projects. They may not be actual real life problems. I can just read it, can be done alone with little or no teacher guidance or team collaboration. This is what is happening now. The teachers are not aware what the student is doing. Student does the project, and one day before the Viva Voce, he comes to the class and teacher signs it, and that is all. They are used year after. They are repeated. Everybody is making a solar geyser. Teacher work starts mainly after the project is complete. That is what I said. Teacher is not involved in the student's work project. Only when it is completed, then teacher comes into the picture, and there is no time for any corrections. The teacher also signs on the project report, and this is end of it. The students do not have open opportunity to make choices at any point in project. They go along a linear path. They don't have branches. They don't branch out. Are based upon directions given by them and are done like the previous years. Are often graded based on teacher perception. Are closed. Every project has the same goal, and result is usually the same. Are not of much help to solve real world problems. It is just for the sake of doing a project we are doing it. Are based generally around tools for the sake of using a tool. Now, why I'm doing this? I'm telling you this. That means we have to avoid these things in the project-based learning. We should not be doing this. The teacher should not be telling what to do. The teacher should not come into picture after the completion of the project. He should be continuously there. He should be discussing. There should be a proper monitoring of the project. So we have to avoid all this. But we have to see how to take care of these things when we are thinking about project-based learning. Now, in PBL approach, it may not start from the teacher at all. The student can come with the project to the teacher, or the teacher gives a problem. The student devises their own direction to solve the problem. Students test and revise their own direction. That means they evaluate. They assess. Assess on what? On technology, on cost, on weight, on safety, on environment. So what are the factors? The students will evaluate. Students get information and develop skills. Students apply knowledge skills to solve a real life world problem, and teacher evaluates that. So teacher is actually always there in this loop. So this is comparison of those three. Features of PBL approach requires collaboration and teacher guidance about the process. Guidance about the process, which is student director. We have talked about this based on real world experience. Real learning occurs through the project. Student choices to determine the outcome. That means he chooses what is the outcome. Now, you will say that I am not talking about project-based learning at all. No, these are the requirements. These are the features. If we have to talk about the project learning, or we have to select a project, these are the guidelines for selecting a project. I'll come to some projects also which I have listed. That is basically interdisciplinary projects are there. You can write your own projects also. In project-based learning, design elements, there are 6, 7 elements. One is, it is a challenging problem. The project is framed by a meaningful problem to be solved or a question to answer at the appropriate level of challenge. You see, project-based learning, let's say in our institute, university here, we have implemented in all these years. So now, depending upon what is the level of the student, you have to decide the level of the project also. Same project can be continued year after year also. Sustained inquiry. Students engage in rigorous, extended process of posting questions, finding resources, and applying information. This is called the golden rule of project design in PBL. Authenticity. Project involves real-world context, tasks and tools, quality standards or impact, or the project speaks to the personal concerns, interests and issues in the students' lives. Level has to be where the students can solve it. Student voice and choice. Student have the choice. Decision is based on discussion with the students. It is not a forced question. It is not a forced project. Students make some decision about the project, including how they will work and what they create, and express their own ideas in their own voice. Reflection. Student will reflect. I have talked to you what is reflection. Critique and revision. The students are open to criticism and feedback at all levels. They listen to the feedback, they listen to the criticism, as well as they criticize the other things. And maybe we expect that the students make their project work public. ऐसा नहीं है that we will make the project और छुपा लेंगे, किसी को दिखाएंगे नहीं कि मेरा तो ठीक नहीं था, टीचर ने तो मार्क्स लगा दिया, ऐसा नहीं है. It will be open. Like Chandigarh University did, they had a project exhibition where people with good projects were given prizes also. So what happens? PBL ensure that students are responsible for their own learning process. A clear purpose of all learning activities, we know why we are doing it. Sufficient attention for communication skills, balanced support from technical experts to overcome knowledge barriers. Students may not be knowing anything, they have to be connected with people who know the problem. The teacher may also not be knowing, but I expect that the teacher should know it. The major problem here is that the teachers are not involved. Teachers do not have the idea of how to make a project, how to write the project, and how to evaluate it, or what are the methods of doing it. So the teachers have to put in some work in this direction. Let's say real life projects. It's a battery rickshaw for use in Shimla. We have seen a battery rickshaw in Chandigarh, in Mohali. System is available. But what are the issues which will come when you have to make a battery rickshaw for use in Shimla? Give it to the students. Let them think. What are the differences required? Why this problem has come? What is different in Shimla as compared to Chandigarh and Mohali? Will it affect the materials? Will it affect the power motor? Will it affect the battery requirements? Will it affect the drive system? Instead of chain, will you have gears? Will you have different types of brakes? What will be the weight of the rickshaw? If you can do that, that means the student will learn many things. He will learn the design also. Then another problem. I have many other problems. But water filtration system designed for new sectors of Mohali. There are new sectors being added. What type of water supply system, filtration system we should have? How to meet the requirements? What are the What is the difference between the new sectors and the old sectors? Old sectors had only 3 stories. Now there are 20 stories. How it will be different? What will be the difference in the design of the piping system, design of the pipe itself, design of the distribution system, laying of the pipes? What is the pumping system? What is the filtration system? How to take care of this increased load on the water consumption? How to make the, maybe connected with this is disposal system. So it says, if you do this work, what type of learning will be there? Understanding and applying the basic design process. How do we do it? Let's say rickshaw. How a rickshaw is designed? What are the factors? What is the load it can take? Critical and creative thinking. The students have to think critically, and maybe they say this is a wrong design as far as Shimla rickshaw is concerned. I will replace it with a new thing. Evaluation of alternatives. He can evaluate. Maybe the chain drive is not good there. Maybe the rear drive is not there. It is being pulled from the rear. I will put a front wheel drive. What are the alternatives? Financial evaluation, how much it will cost. Will the cost be so much that people will not be able to buy it because they will not get the ROI on this, return on investment in this. They will not get enough return of investment. That means you have a rickshaw and nobody sits on this because you are asking for more money, because you have spent more money on purchasing the rickshaw. There's no use of making it. Project planning and management, how to do it, how much time it will take, what are the steps in this, and how to monitor this. Written communication, presentation, and design, and confidential level, autonomous or maybe a teamwork. Awareness of culture, ethical, economical, and social needs. Is it required there? Or what type of things are there? Maybe I don't want that the the person sitting on rickshaw should be getting down from the right side because there are chances of accident. How do you take it? Ethical. Sometimes color of the rickshaw is maybe a problem. There will be some cultural issues. Then, as I said, projects may be assigned in appropriate semester based on learning requirements. This I wrote actually. Very, very simple things. I just sat on one day. I said, what type of project you should give for project-based learning? I looked at the laboratories in the mechanical engineering department. I thought what I have written here is digitization of laboratory experiments with an aim to convert mechanical displays into digital displays. We have in labs, we have analog displays. What I wanted, that we will give it to the students, that convert these displays into digital displays, change it. There will be a lot of learning with this. First, they will see what is the entity which is being measured. It is pressure, temperature, flow, velocity. What is the density? What is this thing? Quantity you are measuring. What is the range of instrumentation? How can I replace it with digital display? What are the digital elements there? What are the sensors which I can use? Can I have all data on one display? So he or she will come up with alternatives and evaluate them. Evaluate them based on the sophistication, based on the cost, based on the time required to fabricate it. And in the process, he will learn many things. He will learn the process planning, and he will learn about the financial aspects also. Uh, second project I did to develop IoT based hardware and applications for hardware, hardware and application for lab experiment. What I wanted is that, okay, you have done it in the first experiment. Now put it on Wi-Fi. How to integrate it with Wi-Fi, and you get all the data on the lab experiments when you are doing the experiments. Instead of you going to the site and taking experiment, you get it on your computer through Wi-Fi. Lot of things the student will learn. To monitor the motion of a moving article and apply corrections to make it reach a prescribed destination. That means a vehicle is moving and you put some sensors and control system on it, which continuously gives you the position, and if there is any deviation, you automatically it makes the correction and it reaches the predefined destination. That there is continuous feedback. How to take the feedback, the student will learn. To analyze the microstructure of a metal sample and link it to mobile application or to computer system through IoT. That means you have microstructure, you have a microscope, maybe you fit with the camera and see the structure, you analyze it, you have a software, just see from where the software will come. Then through IoT you connect it to a computer system, so that by sitting at your seat, you can see what is the structure of the microstructure of the sample, maybe what is the percentage of the elements in it. To develop an application to suggest a mixture of elements for desired mechanical properties of a model. Let's say you are making a composite. What should you mix? You just give the desired strength and you make a software which knows the properties of the material. You say that these are the materials to be mixed and you get the required strength of the composite. These are, of course, based on, many of them are based on mechanical. Too, you can make your own. Just telling you, by sitting for 10, 15 minutes, I have written all these applications. To control the speed of a machine based on surface roughness. In mechanical engineering, surface roughness or surface finish is very important. So if I can understand, if I know that the speed of the machine or RPM of the machine or feed of the machine or depth of cut of the machine affects the surface finish, can I automatically take note of what is the current surface finish being generated by the machine, and can I adjust the RPM? Can I adjust the feed rate of the machine so that my surface finish is in the desired range? To predict the life of a bearing based on some indirect measurements. Let's say there is a bearing in the machine. We know that the bearing is hidden inside the machine. And bearing failure is the main failure for stoppage of the machine, stoppage of the work, or failure of the machine. So can you do something that you see when the bearing fails, the machine will start vibrating, or the temperature of the bearing will increase, or the noise level will increase. Can I pick up these signals and make some system for measurement or for judging the life of the defect in the bearing? To switch on off AC based on occupancy. There are ACs, especially in government offices, which are switched in the morning and they are not switched off throughout the day. What I want that you should have a system. Can we design a system which can scan the room? And if there is nobody in the room, it should switch off the AC. And as soon as somebody enters the AC and enters the room, it should switch on. Similarly, there are, let's say, 3 ACs in the room. If there are only 2-3 persons, depending upon how many persons you decide, only 1 AC will work. If there are more persons, 2 ACs work. If there are more than that, it is full, then 3 ACs will work. To make an electronic counter to count the number of persons passing through a door without counting the persons going in other direction. It's clear. It is like what police people do it to reverse the direction of motion of a road motion. How do we do it? There are many things the student will learn on this. What is the direction? What control the direction of motion? How to reverse it? How to control it with the help of IoT? To calculate the number of rotations of an electric motor required for a given linear motion. I want something, it is like a rack and pinion arrangement. How many rotations or for how much time a motor should rotate at what RPM so that my slide it reaches the required position. To convert rotary motion to linear motion with display of RPM and linear movement. I'm sure these things that you are getting clear. That means there is a rotary motion. You want to convert it into a linear motion. The student will know how to convert it, and then he has to display the RPM and linear movement on a electronic display. How to pick it up, how to display it, how to filter the data. All this will be required to be learned. To convert rotary motion to angular motion, that earlier it was linear motion, it is angular motion now. To develop a LVDT for linear measurement, it is already there. For what can the students do it? Maybe for smaller distances, maybe with more accuracy and precision. To develop an automated XY table where you can have a graduated X and Y movements like you have on CNC machine. To automate, digitize any domestic appliance. So best thing is this, you start learning from your home. Can I automate some process in the house, which are difficult otherwise for the house people? I just take the pace of a press, iron. There is no display of temperature. Maybe it is not required. That is how people have not come in. Can I ask the students, my students, that you automate this iron press so that I can set the temperature and I can read the actual temperature. And of course, as it is happening now with the thermostat, it should cut off when the temperature is reached, and it should. I can set the range that when temperature falls 5 Celsius from the set temperature, it should restart. Develop an infinite speed variation system for a machine. Now we have stepped variation in machine, let's say in lathe machine. Can we have a stepless speed variation? Demonstrate the concept of vehicle tracking for school bus or transport vehicle for supply chain management. Can we do that? If the student does this, I'm sure there's a lot of learning in the discipline, because all these steps, they are inclined towards mechatronics actually, what I have written. I had discussed with some senior faculty member. He says, sir, after discipline mechatronics, I said, no, I am from mechanical engineering, but probably I need that people should do this, and there will be a lot of learning for the students in this. Some more examples. Temperature monitoring system for hidden components of a machine, switching of, okay, similar. So I will stop for 5 minutes and I want to ask you if you have any questions. Any questions, please? Anybody?
Hello.
Hello.
Hi, good afternoon, sir.
Good afternoon, Kanwar.
So, sir, this was a really very informative session. Sir, I have a question that
Yeah.
how educators can overcome challenges related to assessing and grading students' projects in a fair and meaningful way.
Uh, I have. I'm sure that somebody must have discussed the rubrics part, isn't it? It has to be continuous assessment, and it has to be designed prior to starting the work. That means you have to make a marking plan, assessment plan. Unless you have an assessment plan, you will not be able to do fair assessment of the work. Uh, Mr. Karnu Kamar, is it clear? If I'm probably I understood your
Yes, sir.
question.
Yes, sir. Fine, fine. Thank you.
Any other questions?
Sir, I have a second query,
Yeah, yeah,
if you
please.
don't mind. Sir, actually, when students are engaged in project-based learning, actually there is a need to address the time constraint and curriculum alignment. How we can actually, what strategy we should adopt so that they can have a alignment or synchronism with their academics as well as their projects.
Uh, as I said, we have to give the project based on the level of the student where they are now, isn't it? We have to see at what level they have reached, maybe little bit beyond that. The teacher has to have an idea what is the required time span for this. Then only you can do it. Of course, curriculum aspects will be addressed by doing the projects. There's no issue. The students should address the curriculum requirement as well as go beyond the curriculum also. Uh, what is the role of teacher in this PBL? That is very important. The teacher has to see what is the level of the students, what type of projects he can do. Of course, the students have the freedom to select the projects, but the time span, the level of depth, the teacher has to see. There's a lot of responsibility on the teacher in this type of teaching. Whatever teaching new pedagogical approaches you are talking about, teacher is not out of the scene. Teacher has to do work at a different level. So it is the teacher who has to decide. The student's choice is there, but you can limit the scope of the work sometimes.
Great, sir. Great. Thank you very much.